technical session number 20B, client-side virtualization. Kind of expanding a little bit on our earlier conversation, we're going to be describing or defining virtualization and describe its purpose, list some of the requirements needed to set up and use virtualization, describe how to use client-side. We're going to kind of graphically explain or show what it kind of looks like between like a type 1, type 2 hypervisor. And then we're going to talk a little bit about briefly about some pitfalls of client-side virtualization, including some security concerns like VM escape, like we mentioned in the last technical session. So, based off of what you know briefly from virtualization, how would you explain this to a client? You know, you don't need to get overly technical, but you're just basically explaining virtualization to somebody who is not technically initiated.
Can you say it's network attached storage?
Prior to you getting into this class, would you looked at it that way? We're talking about explaining this to a client who doesn't know anything about IT.
Okay.
And network attached storage, I would say, is just more of an external storage source. A computer within a computer. You have entered the matrix.
Hey, you said make it simple.
Okay, I get it. It's creating an instance inside your computer with it sharing the specs of the computer. Okay.
I feel like some of these are a little too textbooky still.
Well, that's why we're getting practice, right? So it's a system where a remote computer has multiple operating systems and can host other computers on its system. It's the ability to incorporate multiple operating systems on a host machine, a second computer within your computer.
Well, you know, you don't want to throw out some of these keywords. Like if I was a customer, I'd be like, "What's an OS?" Like, you know,
Yep.
just saying.
So,
like, I'm your typical blonde person, so like, say it to me like I'm a 4-year-old.
So yeah, we just got to try to find a little bit, you know, more layman terms and kind of explaining it. You know, you could explain it as, you know, it's a way for me to make my computer act like another type of computer. You know, so if I had a Windows computer, I could create a virtual computer that acts like a Mac on my computer and run them side by side. You know, so there's a variety of ways you could explain it to them to where it's a little bit more of a layman's term.
Remind me again, it takes a lot of RAM and processors.
Yes.
For virtual.
Yes.
Okay.
So for each instance that you create, you need to have enough RAM. You have to have a core typically, so like one processor, and you have to have enough storage to be able to handle whatever instance you're creating. So if we're creating a 64-bit version of Windows 10, we're going to need at least 20 gigs of storage space. We're going to need at least, 2 gigs of RAM. And we're going to need at least one processor core, a 1 gigahertz, you know, processor core. So if we have a 4-core processor with hyper-threading, that would allow us 8 cores. We would need at least, or that would act like 8 cores. We would need at least one of those cores for this instance. So, non-virtualized system, like what we typically operate on a day-to-day basis, you have your hardware, which is your computer. From there, on top of that hardware, we would install an operating system like Windows, Linux, OS X, something like that. And then we would put applications on top of it. That would be like Microsoft Word, Google Chrome, what have you. So we put applications on top of it. That is how a normal system is operating. Yes, Artez.
When you use the word instance, you using that in what sense? Like for each virtual computer you make, is that called an instance?
Yes. Correct. Yeah, thank you. Great question. So when I use the term instance, I'm talking about a single virtual machine. So if I have 10 virtual machines, I have 10 instances on my system. So thank you for that, Artez. I appreciate that. All right. So in a virtualized system, we would need to have it turned on, virtualization turned on our in our BIOS. We would need to have a system that was capable of it. And then we would create what is called a virtualization layer. And then on top of that, we would create what are called containers or instances. So this would be like one virtual computer right here, and then you would have another virtual computer here. So like this one may be Windows, Windows 7, Service Pack 3. And then I would have applications that I would typically run on that. And I could go in, turn on this virtual machine and run that as if that was what that was. And then I could create another virtual container or instance and make it OS X version 10. And then I would have, all the applications I need on there. Like I could put, Time Machine, Finder, all that fun stuff would be in there on top of that. And I could download whatever apps I want. You even have Mac versions of Microsoft Windows or Microsoft Office if you wish. So normal system operates like this, but you can think about this piece of it right here all being in a virtual container. So that virtual container gives you whatever operating system you wish and then the applications you wish to install. You just have to make sure you have the correct amount of allocated resources to handle whatever you install. So processing power, RAM, memory, or storage, all that. So all that has to be allocated. Otherwise, your virtual instance will not work properly. All right. Stephen, can you read for us, please?
Virtualization purpose. While workstations can run multiple operating systems, they cannot run them at the same time. With virtualization, the same workstation can run many different OSs simultaneously on different virtual machines. This saves hardware costs when needing to have access to different operating systems for many reasons, including testing software on different platforms, working in a support environment, and developing a new code.
Awesome. So if I work in IT and we have 20 different types of systems that different people in different parts of our organization use, like accounting may use Dell's, like Dell laptops or whatever. R&D may use Mac machines. So we may have different types of computers operating in different operating systems running depending on what aspect of the company we're talking about. And say if I have 20 different kinds and I'm in IT and we have updates coming out, do I want to have 20 different machines sitting on a desk that I have to test the new updates from, Microsoft or Mac or whatever, and have to install it on every single one of these machines and then see if it, works or whatnot? It's not really efficient, is it? But what I can do is create instances for each type of machine that we have. So on one computer, I can create machines that will act like the other ones that we have in the company. And then I can install those updates on them and see how it reacts. Does it conflict with our homegrown applications that we use and cause it to crash? Does everything work well? So I can put these things in these little virtual environments and test them and make sure that everything works okay before I deploy it out to the company, because we don't want to deploy it and crash the entire system, do we?
No.
You know, what if we work in a hospital? How detrimental would it be if we crashed all the computer systems in a hospital? Literal lives on the line, right? So depending on your organization, you are going to have more rigorous, your testing standards are going to be more or less rigorous depending on how much it will impact your business. If you're writing code, you want to see how this application, like somebody's still out there using Windows Vista. So you can create an instance of Windows Vista, run your code on there and see if it conflicts with the older programming. You can run it and see if it works on Mac OS. So you can sit there and take your code and test it against a bunch of different systems, different service packs. So each operating system, they may send out updates every now and again, but then they may send out really big updates called service packs that have a whole bunch of stuff updated, but not everybody does it. So if you're straddling 2 or 3 service packs on the same operating system, you want to make sure each type still works. This gives you what's called a sandbox environment. So it's a safe environment to test these things without bringing harm to your actual systems. And something that you can kind of work on a little bit before you push it out and go live.
Oh, so sorry. Can you repeat that? It gives you a sandbox. Say it again.
So what we do here, like the virtual machines allow us to create what's called a sandbox environment, which is basically a safe environment to test code or to see how things will interact. Like if we're doing updates, if you're somebody who is forensically breaking down viruses and looking to see how the virus works, you may intentionally infect a virtual machine that you have to see how the virus progresses through the system so that you can better understand the symptoms of this virus showing up. You know,
Okay.
when we start talking about the different types of viruses, some are harder to detect and study than others by, you know, basically by how they're designed. Some are intentionally designed to evade antivirus or anti-malware programs. So operating in a sandbox environment using virtual machines gives us a safe way to study these things, to interact with them, and practice our craft.
All right. So earlier I heard something. We was talking about what was we talking about earlier? Oh, the cloud, right? And how something can escape a sandbox state and go, like, how does that relate? Or
So the virtual machines that you're using, like the virtual program, like VirtualBox, is a program in and of itself, and it has updates. Eventually, you know, sometimes there are vulnerabilities to it that need to be patched. So if a vulnerability is discovered and somebody can find a way to get out of that virtual machine, they can infect the host system, not just the virtual machine, and have access to all the other virtual machines on that system.
oh my.
So that's what VM escape is. They're breaking out of the virtual machine and getting into the, you know, into the real machine.
Idle time is double time. Like who, why? Like why would they think of that?
Well, here's the thing is, you know, not all viruses end up being completely bad. Over time, we find other uses for viruses, and oftentimes the people who create these things are very creative people. They think they're very much out of the box thinkers, and they come up with really interesting ways to solve problems and bypass certain situations. And there are many cases where we'll take old viruses because they've solved some problems that have bugged programmers for years, and repurpose it for something good. There's something called the Turing worm that was created, I guess it was back in the early 2000s. and it was pretty nasty little malware, but it had the capability of pushing IP version 6 protocols over an IP version 4 network. So it was able to create a tunnel and push protocols over a network that they had not figured out how to do before. And now we use a version of that worm in order to still push IP version 6 protocols over an IP version 4 network. PlayStation implemented this, I think, in the PlayStation 2 or 3. It was like four, it was a 4v6 tunnel or something like that. So like if you were operating on an IP version 4 network, you could turn on this essentially tunnel or worm in order to work over an IP version 4 network.
That's
So
cool. That's
there
like how
are-
you make. Sorry, I was gonna say that's how you make vaccines. Like for humans, it's like kind of the same thing. You take like a weakened vaccine. I mean, a weakened
Mhm.
virus, create a vaccine out of it. So you're kind of doing that for a computer.
Yeah, so they're taking some aspects of these viruses because like they may have solved critical problems without realizing it, but they were doing it for malicious means, but you can take it and repurpose for something good and productive.
So if they did all that, I'm sure they wiped the virus with a virus.
Yeah, well, yeah. I mean, but they're taking just certain aspects of the code that enable them to do particular things, you know, like the IP version 6 tunneling. Ninja.
So on MacBook, you can run Windows now, right?
Yep.
But you can't run them at the same time. Mac
Well, you
OS
can run
and
a
Windows.
virtual version of it on a Mac, yes. Is you can run a virtual version of Mac on Windows. And there are ways where you can do a multi-boot with either. They call them a Hackintosh. So yeah, there are multi-boot
No,
protocols.
I'm just trying to figure out. So while workstations can run multiple operating systems,
Yes.
they cannot run them at the same time, right?
Yes, they can. They'll have them all running at the same time, and you can jump into them as you wish. But understand, while they're running, they're eating up those resources. So if you
Got
don't have enough resources for all of them, like if you have 20 different types of virtual machines on your computer, but you only have enough to run 3 at a time, you have to make sure to turn each one off before you turn the next one on. So it's less expensive, it's less cumbersome, and it gives you a chance to kind of test things out before you roll it out. And if you want to get your, a feel for some sandbox environment working with some of this stuff, I know you're sitting there going, man, is there anywhere we can practice this? Test out. Chapter 15 has a sandbox environment. You can go in and play around with a bunch of different systems and how they interact with each other. So also, we'll get into VirtualBox and stuff. You can install them yourself on your own computer, which I encourage.
They just updated it too, so you can use it on a Mac again, but it's not like completely stable yet.
What, VirtualBox?
Yeah, they just updated it maybe like a month ago.
Okay. Mac doesn't play well with others, typically. Do you have a question, Engine?
No, I'm sorry.
No worries. All right, hypervisor. Let's see here. Crystal, can you read for us, please?
Absolutely. The hypervisor. The key enabler for virtualization is a piece of software called the hypervisor, also known as Virtual Machine Manager, VMM. The hypervisor software allows multiple operating systems to share the same host. It also manages the physical resource allocation of the VMs. There are 2 types of hypervisions, type 1 and type 2.
So hypervisors type 1, type 2.
Hypervisors.
No problem. Thank you. Again, this is what's managing the resource allocation. Who gets how much RAM, who gets how much of the storage space, all that fun stuff. We break it down into 2 basic types. You have your type 1, which is called a bare metal or native hypervisor. And this basically means it's working directly, the hypervisor is working directly on top of the hardware itself. There is no operating system between the hypervisor and the containers, or between the, excuse me, the hardware and the hypervisor. So there's no operating system there. The hypervisor itself is the operating system. This shares and manages all the hardware resources. This is one of the this is like significantly faster than the Type 2 and more secure than the Type 2 because you don't have the host operating system weaknesses on top of anything going on with the hypervisor itself. So examples of this, talked about earlier, Citrix, Zen Server, Hyper-V. Those are types of Type 1, or also known as bare metal or native hypervisor. So there's no operating system between the hardware and the hypervisor. The hypervisor itself is operating as the operating system. And that is, you build the containers on top of that. Type 2, this is client-side virtualization. This is mostly what we will be dealing with in this class, where you will have a host operating system, and then you will install the hypervisor on top of that, so long as your operating system supports it and is allowed to do it. So typically all you got to do with modern computers is go in and turn it on in your BIOS, and you're pretty much good to go at that point. The host hypervisor is heavily dependent on the host operating systems for what functions it is able to perform. And then the operating system that runs inside your virtual machine or container is called a guest OS. So you have the host OS, which is your main system. Like if you're operating on a Mac, it's your Mac OS or OS X. Then if I was running Windows on it in a virtual box, the Windows version would be the guest OS. This one typically is good for testing applications, using, if you're developing code, testing your code on different types of machines, see how it works, creating what are called honeypots and honey nets, which is essentially setting up fake systems to try to lure hackers in and distract them away from your actual systems. So they do this for two reasons, the honeypots and the honey nets. It's typically to, one, try to track down who the hacker is, and two, to try to study how they're attacking the systems, what methods they use, and how effective they are. So if they find new ways to bypass security and get into your system, you want to be able to monitor that and see how they do it. So you'll set up fake data and stuff like that for them to try to interact with, so that they will spend more time working on that rather than going after your actual systems. Examples of Type 2 hypervisors are VMware and Oracle's VirtualBox. Most people tend to go with Oracle's VirtualBox. It's a free one you can download, and it's relatively easy to set up. All right. So here's kind of a breakdown just to kind of show you visually how they break up. So in the Type 1, so something a little bit bigger, you have no operating system in between. The hypervisor is operating as its own virtual machine. And then you have guest 1. If I could draw a straight line, that would be so awesome. And then guest 2. So you have two containers sitting on top of the hypervisor itself. So there is nothing between the hardware and the hypervisor. The hypervisor itself is acting as the operating system. The only difference between that and Type 2 is you have the host operating system here sitting between the hardware and the hypervisor. And you still have the two containers set up here. Questions on this? Yes, Nassim.
So the type 2 hypervisor, they uses more resources because they have a operating system and the hypervisor.
Correct.
Right.
Yes, absolutely. So you have to have enough resources to run your host operating system as well. So you have to have the amount of storage, RAM, and processing power to run the host operating system. So if you had, say you had 2 cores, but with hyperthreading, you had 4 total instances. Your host operating system would take up one of those. And then you could have 3 virtual machines on top of that. Does that make sense?
Yes, thanks.
Because you would need the resources for at least the one. So excellent point, Nassim.
I have a quick question, please.
Yes.
My question is, so would you say that like a hypervisor would be more suitable like for like a medium range or long range networks like a WAN or LAN? And so for maybe like a smaller network, it would be optional. So is it like something that's more geared for medium or large size network, or is that irrelevant? I just wanted to ask. Thank you.
No problem. I believe the size of the network is actually irrelevant to whether or not you would use this. Because even in a small company, if you have 5 different employees, but each employee brought their own computer to work, because it's a small startup, you would still need to you could still create virtual instances to test software before you deploy it to the company. So this actually helps keep costs down than trying to maintain duplicates of every type of system you have in the company in the IT department so they can test it. But good question. Any other questions? All right. So client-side virtualization requirements. We briefly mentioned this before. Running multiple operating systems on one physical workstation require more resources, obviously, than the original host had or would need. So we're going to be assuming at this point that we're going to be dealing with a type 2 client side. And so you need the host OS resources. So if we had a version 10 of Windows, you would at least bare minimum 2 gigs of RAM, 20 gigs of hard drive space, and at least 1 core of processing power of a 1 gigahertz processor with 64-bit architecture. Now, typically most systems comes with a lot more than that. We have multi-core, we have hyper-threading, all that kind of fun stuff, which allow us to create more instances, but we need to make sure we have enough storage and enough RAM, because you can eat up RAM pretty quickly. And understand when you allocate those resources to the virtual machine, as long as that virtual machine is on, those resources will be dedicated to it. And when you turn it off, it'll free up processing and RAM power. The only thing that does not get freed up typically is your storage space, because you have to maintain the operating system and all that stuff in there as well. Questions? So hardware requirements, let's see here. Babukar, can you read for us, please?
Oh, that's a lot. CPU. Oh, do I start on top? Okay. Requirements, hardware resources. CPU. A multi-core processor is recommended since the hypervisor can treat each core of the processor as a separate virtual processor. And it even create multiple virtual processors out of a single core. Some hypervisors require a CPU to be specially designed to support virtualization, Intel VT or AMD V. In most cases, it must be enabled in the BIOS before hypervisor will install. Memory is also the major concern with using virtualized instances. The hypervisor allocates the existing RAM between the host operating system and each VM. However, each operating system installed needs to have at least the minimum RAM requirement required in order to run the VM. If the host operating system requires 4 GB RAM, the guest operating system requires 2 GB RAM, then you would need a minimum of 6 GB RAM. Recommendations for installing a hypervisor and VMs includes a hardware-assisted virtualization and 15 GB free storage space for each instance.
Excellent. Thank you, Babakar. So 2 big things should stick out to you on this page. So the first would be enabling the hypervisor in the BIOS. Who remembers doing this lab? We were doing the BIOS lab. Remember that? We actually went in and turned on hypervisors, right? Apparently just me and Stacy. Oh, hey, Casey too. Awesome.
There's a lot of labs we did.
There's a lot of labs we did. Come on, we're supposed to memorize each individual instance. But don't worry, you'll get a chance to go through those labs again. We do like to cycle through them as well. All right. The other thing that should stick out, if you remember, we had a question on a previous test where it said, if an application says we need 4 gigs of RAM, what does that mean? And the system requires
it's just
4.
for that just for that application.
Yeah. Well, no. So if the application is requiring 4 gigs of RAM, it's just basically saying overall the system needs to have that much. It's not
Right.
saying it needs
Plus more.
4 additional for that application. It just says the system needs to have at least that much. For a virtual machine, if you have a 4 GB requirement for your host operating system, and then you have a 2 GB requirement for your virtual machine, so your host and your guest, then you add them together. So if it's just an application, it's total RAM. It's, basically you need to make sure the system has at least that much. But when you're doing virtual instances, you have to add it together. So you have your host OS, which would be like in this instance 4, and then you would have your guest, which would be 2, and you have to add those together in order for them to be able to work. Does that make sense? Kind of separating those two out a little bit. All right. We all did this lab. We will do this lab again. You have to make sure you go into the BIOS or UEFI, enable virtualization technology before it will even allow you to install and turn on your VMware or VirtualBox. It actually could. And you can test yourself on different types of systems as well, Kev. Practice with them. All right. So, network requirements. So each virtual machine you create can have its own individual IP address. So if you have 8 virtual machines on a single computer, each virtual machine will essentially have its own IP address. And you can either have it generated by a DHCP or you can put it in yourself manually. This is how we would be able to spoof an IP. If they're using IP security. Also, each virtual machine will create a virtual NIC, so virtual network interface card for each virtual machine. And guess what? Each virtual NIC has its own MAC address, which can either be generated by the virtual machine or you can put it in yourself, which is how you spoof a MAC address to bypass MAC filtering. Yes, George.
So the little mini lab you gave us yesterday about changing the settings on a router, it actually
Mhm.
had something where I can change the IP address. Is that similar to this, or is that completely different?
Like change the IP address to your like internally.
Yeah.
Well, yeah, you can set up your own range and IP groupings if you wish. But say I'm outside and we have static IPs inside, I can spoof an IP address to bypass IP security if I wish. You can put in your own IP as well for your regular NIC, but this is a way you can do it as well. It's another way you can do it.
Okay, I think maybe I asked the question wrong. So the program you gave us yesterday where you virtualized a setup for a router,
Mhm.
there was an option for one of the routers that I was playing around with that you can change the IP address. Is that the same thing as this, or is that completely different?
I would say it's similar.
Okay.
But again, if you're putting in a routable IP, it has to coincide with what your internet service provider gives you
Gotcha. All right.
for a
So this is-
forward-facing IP.
and this is just-
Internally, you can kind of do whatever you want.
Mhm. So this is spoofing it completely, like faking I guess a provider router's IP. Okay. Got it
Yeah,
now.
or you could just have it go to the DHCP and get new ones anyway. So you can do it either way. But the MAC address thing is really the big one because you can input your own MAC address and bypass MAC filtering with the virtual machine.
Got it. Yeah, because you can't change that normally. Got it.
Yeah,
Thank you.
and it's pretty easy to do in this case. So the virtual NIC does not have to be connected to a physical one. So you can set up a virtual NIC, and then you can set up what's called a virtual switch inside, and the virtual machines can talk to each other, but they can't get out to the external network unless you connect it to your physical NIC. So you can create a little network inside your computer where they can only talk to each other, or you can set it up to where they can talk to the outside world. If you're playing around with viruses, I would definitely not set it up so you can talk to the outside world. So here's kind of what it looks like. So you have each virtual machine inside here. Each virtual machine has its own virtual NIC or VNIC. You can create a virtual switch inside your computer so that they can talk to each other. But for them to talk to the outside world, you would have to connect it virtually to your physical NIC, and it will ask you if this is something you wish to do or not. So you're creating essentially like a little network inside of your physical computer. And then once it goes through your NIC, you could connect it to a physical switch, and then it's a piece of your network if you wish. So call it internal networking if they can only talk to each other. We bridge it to our NIC if we wish it to connect to the real world, including the internet. Questions?
So the second one would be the system to lure in hackers.
You could set it up to do that. Yes, you could set up honeypots that way. If any of you guys ever watched some of the YouTube videos where you get the guys trying to trap the hackers, like the ransomware guys, and they try to draw them into their systems or whatever, this is how they're doing it. They're creating virtual machines. And when they allow them in, they put them in a virtual machine so they can do no harm to their systems. But the hackers typically will be able to gain access to the guys trying to install ransomware. Yes, Casey.
Sorry, if this is a redundant question or not, but to use a virtual switch, does it have to be linked to your hardware switch for it to be used?
No.
Okay.
So the virtual switch is internally so that they can talk to each other. If you have multiple
Right.
VMs, you have to have a virtual switch so they can communicate with each other.
Right. I thought for some reason you needed a physical switch to have that virtual switch.
No,
That's what
no, you don't. What it basically is like if you're going out to the physical world, you would have a NIC and then you would connect it to either your network, directly to your network. But, you know, in an enterprise environment, it's typically may connected to some form of switch and then onto the rest of the network. So. All right. Questions on that? I would take a screenshot of this image here. I did receive at least 3 to 4 questions with regards to if I had 3 virtual machines, how many virtual NICs would I need, how many real NICs would I need, and how many switches would I need. So they like to ask, questions kind of like that.
Hey, Kelly,
Yes.
when it comes to those ransomware hacks and stuff like
Mhm.
that, do they hack into the system? And then so with the gas shortage, how do they know it's a real hack or not? Like, how do they know the person's not lying?
Well, typically if a ransomware is installing on your system, they're encrypting all of your files and they're basically saying, pay me or I won't decrypt your files.
Oh.
So you know.
Okay.
You know.
Thank
And
you.
if anybody remembers the Continental hack, they didn't actually hack the pipeline because the pipelines are run on what's called SCADA systems, which have an air gap between networks and them. So you have to have physical interaction with them. There's no way they can actually connect to the wider network. But what they did do was they hacked the billing systems and administrative systems. So there was no way they could get paid. And that was why they were shut down. So fun stuff. All right, security requirements. So anything you would worry about security-wise for an individual computer are the same you would worry about for individual virtual machines. So if these things are opened up to the network, they are as vulnerable as any other machine. And a lot of times, even more so, because people tend to forget that you still need anti-malware and stuff like that on each of your virtual machines if it is going to be going out into the regular internet. Your host antivirus software and all that stuff is not going to protect your virtual machine. They are containered away from each other. Yes, Crystal.
Hey, Kelly.
Yes.
What about free anti-malware and antivirus apps on your phone? Do they protect from this kind of stuff also?
I'm always leery of free antivirus and anti-malware stuff because a lot of times people offer that up as a way to kind of get you to invite malware into your system.
Yeah, I feel you.
I would be leery of that.
My dad's a big fan of Avast.
Avast?
Hacking. Yeah, Avast.
Okay, I'm not familiar with that one. Avast?
Avast.
Like Victor,
Like
A-S-T.
Avast me Hearties.
Mm-hmm.
So, okay. I'll have to look into that one. I'm not familiar with that one.
His virtual Bible is CNET. So if there's a link on CNET, he's gonna get it and he's gonna download it and he's gonna refer people.
Got it. There you go. So, sorry, VMs are as vulnerable to hackers and malware just like any other machine. So we need to be aware of that and understand that if it has access to the internet, it must be protected. And if you can't protect it or don't want to go through that kind of trouble, just don't let it have access to the internet. All right. Yes, Nassim.
Saying that there's an alternative, maybe you don't save that instance, you exit the instance and without taking a risk. If something happened, you're not sure. That's
So yeah, if you leave it running and you walk away and it has no antivirus on it, you're basically leaving just a back door to come in and basically rip your computer apart. So,
but if you feel that something might have happened, someone might have break into your system, your virtual system, then you just leave the instance of the. You don't save it, and then nothing is.
Provided they don't do a VM escape, they're not able to do a VM escape. You would have to delete the instance and then restart a new one to get rid of it. So, but yeah, you are correct on that, Nissim. So you must ensure any guest operating system you have has antivirus programs that are kept up to date. as well. Just like your regular systems, there is general maintenance that needs to be done on the virtual machines as well. Now, sometimes you may hear the word emulator kicking around. Is an emulator a virtual machine?
Yeah.
Not really. So an emulator serves a single purpose. It runs one type of program on a platform that is different. So has anybody ever used like an old console emulator for like older video games or stuff like that? I've used those before too. And typically what happens is when you're running that emulator, it's eating up all the resources to it, even if it doesn't require all of them to run, but it basically is tying up the whole system. And it typically is much slower, and it tends to bog your system down heavily. So instead of running an emulator, it may be much better to actually run a virtual machine with that specified operating system on it than trying to run an emulator of that, whatever you're trying to do, be it a console or what have you. So creating a virtual machine for it would be more efficient. Yes, Ramon.
Is there an emulator for iOS? Because I usually notice the ones that are around are morely for Androids.
I do believe there is an iOS emulator. I'm not sure where you can get the free code for it, but I am fairly positive that somebody out there has one. So I don't know. Have you heard of one, DW?
I think Smart Face is iOS, right?
Smart what?
No, I
Smart
haven't.
Face.
Smart. Can you type that in chat, please, Babacar?
Smart Face. F-A-C-E.
Smart Face
Mhm.
is iOS emulator.
Yes, I think so.
Okay. That may be one worth looking into.
I have one for Android.
Yeah, Babacar.
That's what Ramon was saying. He's like, he was able to find ones for Android, no problem. It was the Mac one.
Android has a lot of them.
Yeah, Babacar, SmartFace, Appetize, IO, Corlium, and Xcode. Those are the ones I just looked up.
Yeah,
Okay.
those are Apple. Yep. There you go.
So start trying to separate the difference in your vocabulary between an emulator and a virtual machine. So hypervisor emulates hardware and presents this virtual hardware to each virtual machine. And the hypervisor also supports multiple operating systems where an emulator supports one specific operating system. Whatever it's trying to achieve, it can only do one of those things. Where virtual machines, you can set up multiples. And the only requirement for the emulator is that it is compatible with a host operating system. That's it. All right. So emulator can do one specific operating system, or virtual machines, you can set up multiple instances. Yes, Nassim.
So an emulator, you don't have to set it up, you just run it.
Yeah, typically it's just, yeah, it's set up, you plug it in, it runs on top of whatever you're working as long as it's compatible, but it tends to bog down all the other resources. And you can only do that one thing when it's running. Virtual machines, I can have multiple virtual machines running and not be a problem as long as I have the resources. All right. VDI, or virtual desktop infrastructure. So this is essentially the process of running your like a user's desktop inside of a virtual machine that lives on a server, usually in a data center. A lot of companies will do this because it gives them greater control of the data. It's also less expensive for them to, have 1,000 thin clients versus, a thick client for every single individual. And then you run everything remotely. Your data is secure. If somebody comes in and steals a computer, they basically have the computer, not the data. So they have the hardware, but not the actual proprietary information that's on it. It enables you to personalize your desktop, which is really cool. So you can basically make your desktop look like you do at home. You can do the really cool, unique backgrounds that Casey is so fond of. And then every time you log in, it doesn't matter if I log in at my computer or if I'm like, traveling to New York and DW lets me use his computer, I can log in from there and I still have my own virtual desktop, my own one. It looks the exact same as when I was using it at home. It doesn't matter where I log in. It still looks the same. I've personalized it, everything I know where it is, and it creates that virtual environment for me. So it allows you a lot of freedom. You don't necessarily have to carry a laptop with you everywhere if you don't want to. Like if you're traveling from office to office, you can literally hop into whatever desk is free, log in, and you're off. Questions on this? And this is server-based virtualization.
So you can run a virtual desktop like a browser.
Yeah.
You can go anywhere. And
Well,
log in.
everything. So like you would basically, when you turn the computer on, it logs in as if you're logging into your regular computer, but it's just connecting over the internet, logging into the servers, and then wherever you are, it brings up your personal desktop.
So it just follows you everywhere you go.
Yep.
Cool.
So all your files are with you, whatever, things you've updated or personalized or all that fun stuff, it's just the same for you. Took the words right out of my mouth, George. Yes, Nazim?
So is this the same concept as a software as a service that we spoke about before on cloud?
It's, similar, but VDI is a very specific thing where you're setting up a virtual desktop for others to log in and use.
Because in the quiz there was coming up this VDI together with the other ones. So I was wondering if it was.
Yeah, so what you're looking for in VDI, it is a virtual desktop that allows for personalization, and it is highly mobile. So wherever you log in, you always get the same thing. So if I log in and then log out, and then DW comes behind me and he logs in, he wouldn't see my desktop, he would see his. All right.
And how do you set that up? Can you
What, the virtual desktop environment? Well, you set up a hypervisor, and then you would set up virtual instances or whatever, these desktops for people to personalize or what have you. And then when you set up the thin client, you know how you prioritize your boot order. You would put in your boot order the IP address of the server. So you would log into the server, and then based on your login, it would connect you to the correct virtual machine.
Okay. Pretty cool stuff.
Mm-hmm.
Thank you.
Absolutely. Again, the moment you stop being scared is the moment you start having fun. Get in the habit of tinkering with things. Start messing around with it. All right. Using client-side virtualization, general steps. When using client-side, you determine the client's need for it. Is it something that would benefit them? Is it something that would benefit you in the IT field? After that, you would evaluate the resources available on your computer to see if it can support the virtual machines you're trying to create. Look at your CPU, your RAM, hard drive space, and network connections. Are you going to use a type 1 or type 2 hypervisor? More often than not, at least especially in small to mid-sized businesses, you will be using a type 2 client side, and also in the IT field as well. And then what security requirements, what are you going to be storing on it and saving? Is it just for testing purposes, or are going to be these more permanent instances for you to continually test on? And after that, install the hypervisor and the guest operating systems. How do we do that, you ask? We're going to go through the next slides pretty quickly. Download VirtualBox and install it on your system. It's free from Oracle. You can Google it. It'll take you right into downloading it based on if you have a Mac or a Windows machine. You can download it right away. You go through, open it up, create a new instance. So you go to machines right here, click new. You're going to start your machine, name it, give it something that you know what it is. Just don't say virtual machine 1. You know, you might say Windows 10 Service Pack 3 Dell. Something along those lines. So create something at least so you know what the virtual machine is.
Can you change the name later, or is
What do you
it's
mean?
fixed? Let's say you give a name and you're not happy later on, you want to change it. Can you change it later or
You can duplicate it and rename it.
duplicate the name?
Yeah, I think you can rename it as well. But like you can duplicate your own ones. Like you can create, like if you create like a really good one and you don't want to run the risk of ruining it or whatever, you can create a duplicate of it and only run the duplicate and then just duplicate from that each time. So you know, in case it gets a virus, you don't have to delete it and then start over. So you select the operating system you're going to use, Microsoft Windows, Windows 7, Service Pack 3, whatever, you know, what have you. So select whichever one you want. It'll set it up. It's ready to go. You start allocating RAM and hard drive space. How much do you wish to dedicate to this machine itself? So you'll take your slider bar. It'll put in red what is needed for the host operating system. And then you can select from what's available and then allocate however much hard drive space you wish. All that fun stuff. You can also create things like you can allocate other things, like you can allocate certain USB ports, your physical USB ports. You can allocate the optical drive if you wish to one virtual machine. You can allocate any peripheral that you want specifically to that machine if you wish. So in here is where you would do this. Do you want it to have access to the printer? If you have multi-monitor display, maybe have one virtual machine on one monitor, one virtual, and then your host machine on the other. All kinds of fun stuff like that. After you get everything set up, you've got all the fun little peripherals and settings the way you like it. You can turn your virtual machine on, and from there you would install Windows as if you would on a normal machine. Once you go through the installation process, you are pretty much up and running at that point. You can test whatever you need to test, practice in there, run it just like it's a normal computer operating system, do whatever you need to do. And then when you're done, always make sure to power off your virtual machine.
Kelly, I've been really good, but you say so many things and I think of songs and I just thought of the Chris Brown song. Let me see if you can run it, run it. Was anyone else thinking that? Sorry.
I like it. So again, you do have a student paced version of this, so you can go through each step one by one. If you want to try installing it, I highly encourage you going in and trying to install and run a virtual machine on your own computer. It's fun to play around with, to kind of do different things. If you're not sure if you want to get into the Linux world, you can download a version of Linux and install it on a virtual machine and see if it's something you like and you want to mess around with. Although after you do some of the Linux Coursera labs, you may wish to never see Linux ever again in your lifetime. But I will remind you that Linux is valuable in the IT field if you are proficient at it.
Which version you suggest?
It depends on what you're getting into. I mean, to start out with, I would go with Mint or Ubuntu.
Ubuntu Mint.
Yeah, I mean, if you're going to get into security, Kali, obviously. If you get a little bit heavier into security, get in with Black Arch, although it's less stable than Kali because it has a lot of security tools on it. And if you start playing around with Kali, just make sure you don't go poking around other people's networks because, as I like to say, if you do that and they don't like it, guys in suits may show up to have a conversation with you, and nobody wants that.
Yeah, the Kali Linux is
Question.
pretty cool.
What if it was in good humor just other networks around like you know?
Well, if you're
That's so
poking around
you-
people that you know, okay, that may be one thing. But if you sit there and you start poking around Amazon and be like, I was just kidding, they're gonna be like, no, I'm sorry,
Yeah.
we need to go have a conversation. So
Watch, you guys are gonna be seeing a lot of my kitty photos, you know, but
there you go. I haven't messed around with GNOME Sim, so I can't speak to that one.
Okay, thanks.
so essentially everyone in class is okay, target. So it's just say
Depends
that
on the
right there.
relationship you have with your classmates, I would say. So, but Kali is pretty fun. There's a lot of cool stuff on there. If you have multiple computers in your house, you can set up like virtual networks and then try to see if you can get into the other computers and stuff like that. You can download, there's a ton of security tools that are free, like Wireshark. You can sit there and capture all the wireless packets from the entire that are being transmitted over the air and look at them. So like you can sit there, if people are using Wi-Fi in your house, you turn on Wireshark and it literally draws in all the packets. And then, you know, if they're not using any encryption, you can quite literally read the packets too.
I want to be a creep so bad. I want to do it.
Is this what you were talking about before, like where people sit in Wi-Fi, I mean, coffee shops and like filter the
Yes.
Wi-Fi out? And,
Yeah, they just
wow,
turn
that's
on
crazy.
Wireshark and it literally, and they don't have to do it right then and there. It just takes in all that data and then they stop whenever they want to stop. They go home and then they can sift through the data and find what they need.
The urge is strong to be a creep, guys.
So there you go.
Seriously.
Just being like curious, like
All right.
Kelly, I have a quick question.
Yes, sir, Babacar.
Okay, if you want to remotely shut down your computer and turn it off within your household, you know, you can use the wake your LAN.
Yeah, Wake on LAN.
But yeah, wake on LAN. So what if you were like in Texas having computers in New York?
Yeah,
What do you
as long
use?
as you can get into your system, you can use the Wake on LAN. But for something like that, I would use a port forwarding system where I would go in through some random port. I wouldn't like set it up on a common port where anybody can stumble across it. But yeah, you could do that. You could do that remotely.
I've been wanting to do that, but because right now I just use a team viewer and it's not like I'll have to leave my computer on so I can access files from,
Yeah,
you know,
no, you
from
should.
Texas
You
to
can
New York.
use Wake on LAN for the same function.
Oh, okay. I need to learn how to do that one. Thank you.
Mm-hmm. All right. Pretty close, pretty close. So power off the machine when you're done, so you free up those resources for everything. Some of the challenges with virtualizing, setting up the environments, kind of no different than doing a clean install on a regular computer. You can have, just like any other computer, you can have tons of installation issues. Basic way to get around it is follow the installation steps that you normally would. If you run into an issue, you can always delete the instance, reinstall, because maybe it just didn't take the first time. And the same issues you would use to resolve regular installations is the same thing you would use on a virtual machine. But also, don't be afraid to just delete it and spin up a new one.
sounds like me and shoes.
There you go. So another issue is that it uses up resources that would also be needed by the host. If you're running a little too close to the wire with the resources that you need, it could cause things to drastically slow down and possibly crash. If you're running really close to it as well, also making sure that you're turning off your VMs when you're done so that you can free up those resources for the host to use again when they're done. And lastly, security concerns. So you still have the same malware concerns, you have the same firewall issues, malware. Make sure all that stuff is active and up to date if you're going to be allowing these things to have internet access. And basically what you would need to do for your regular system is the same thing you need to do for your virtual machine, and make sure everything is kept up to date, because It might be terrifying to you to understand or know how many new viruses are discovered every day. It's in the 5-figure range. Yes, Ramon.
So is your location hidden while using the virtual machine? Or you can't
No,
be
because it can't, I mean, as long as you have VPN, yes. But if you're not using any kind of encryption or VPN like that, no, it's not. Because it has to pass through your physical NIC, so your location can be found that way. It's all about the layers. All right. All right, we're not going to do this one. But I wouldn't want you guys to feel neglected. So we did throw a little test in there for you.
So it's fine. You can neglect me.
I wouldn't dream of it.
Dang, I thought that would work.
No, we call it tough love, you know. I'm tough on y'all because I want to see you succeed. Stop here.